Hello, this is Ms. DB. In this video we are going to learn to solve compound inequalities and how to write the answers to compound inequalities. So a compound inequality is when you put two inequalities together. And you do that with either the word or, like in this example A here, or the word and. And an and problem is often written as one compound inequality without the word and. Or it can be written as two separate ones like in here. So here's how you do these problems. There'll be two different methods depending on whether it's an or an and. An or one, you will do the two parts. You can do them separately or you can do them on the same line. An or compound inequality almost always has two separate parts on the number line with the lines pointing in opposite directions. If it is an and compound inequality, which like I said often is written as one combined inequality, then you will end up with only the part where the two inequalities would overlap. So you'll have your endpoint mark and a line in between them. That's because if you graph the two separate parts, the first one is -1 is less than or equal to x, which is the same as x is greater than or equal to -1. If you graph that, you have a solid dot at -1, an arrow to the right, and then you graph the second part, which is x is less than 3. For and, it means it has to be true for both of them. So it's only the part where that would overlap. So when you graph this, you won't have any arrows. You'll just have your two endpoints and the line in between them filled in. All right, in numbers 1 through 4, the number line is marked with the solution to the compound inequalities, and you need to figure out what is this showing? What are the inequalities that this shows? So number 1, I'll do 1 and 2. Number 1, because there's two endpoints and the line in between them is completed, filled in, then I know that this is an and type. So and combines two inequalities, and these are the inequalities. So the first one, it looks like they put a solid dot at -40 and then they started going to the right. So that would represent that x is greater than or equal to, because it's a solid dot, it's filled in, and it would be -40. And then use the word and then it's also combining an open circle at 60 and an arrow to the left. So that represents x is less than 60. Now you need to put these together into one inequality because ands can be combined. So to combine them, the x goes in the middle, the two endpoints, the lower endpoint is on the left and the upper endpoint is on the right. And the easiest one to fill in is this one, because x less than 60, that's right here. You just need the less than sign. It matches exactly. But this one is flip-flopped. Instead of x greater than or equal to -40, we need the x on the other side. So the other side, x is greater than or equal to -40, is the same as -40 is less than or equal to x. These are equivalent expressions. So now I can see that for this, it needs to be written like this, so I need the less than or equal. So when it's all said and done, the answer for number 1 is -40 is less than or equal to x, which is less than 60. So in other words, x, the number, is between -40, and it could include -40, and 60. So that's an and one. The or ones are a little easier. You just have to figure out both parts and put or in between them. So in number 2, this first part of the graph on the left side is showing x is less than -2. Then you put your or, and on the other side, this is showing over here, this is showing x is greater than or equal, because it's a solid dot, 5. That's it for number 2. So the ors are a little bit easier to write. In 5 through 9, you're going to match the inequality written in symbols on the left here with the graphs on the right. So be very careful. Check your and or your or. Remember 5 and 9, those are ands. Even though it doesn't have the word and, they combine them into one inequality, but that's really what that means. Alright, so now we're going to look at when it's not just already solved for you. So in this example here, we have 2 is less than x plus 3 is less than or equal to 5. There's two inequalities combined here, and it's and. We looked at how you can take an and combine it like that. So we're going to write them as back as two separate inequalities. So the first one is just right to there. 2 is less than x plus 3. The second inequality is x plus 3 is less than or equal to 5. So we write that one. Two different problems to write. Write them both. Don't try to do it without writing them both. It gets trickier. Once you write both of them, we're going to solve both of them. So to solve this for x, we just need to subtract 3 from both sides, and we get negative 1 is less than x. Solve the other side, you get minus 3 from both sides, you get x is less than or equal to 2. You don't really have to graph them on two separate number lines as they show. You can draw one number line and then start graphing each one, but don't make your arrows go very far. So x or negative 1 is less than x is the same equivalent expression as x is greater than negative 1. It's easier to graph if the x is on the left side. So here's negative 1. I'm going to put an open circle and I'm going to start going this way, but I'm not going to go very far. Now I'm going to graph on the same graph. Let's see, this would be 0, 1, 2. I'm going to graph x is less than or equal to 2. So I have to do a solid dot at 2, and then I'm going to start going to the left. So the two lines are going to overlap. My x is greater than negative 1. I was going to the right. My x is less than or equal to 2. I was going to the left. But what I get is the line between them is completely filled in. So this is the graph of this. The solution would be if I combine my two parts that I got this and I got this, or this and this. Again, you put your lower endpoint on the left, you put your upper endpoint on the right, x is in the middle. This one you can just translate directly. Just copy down the sign was x is less than or equal to 2. I already had this one in the right form. I just changed it so I can put that. These will usually both be less than or both be greater than. It's very rare for those to be different signs. So keep that in mind. A lot of people somehow think that it should be like this, but it's almost never that. That doesn't really make sense. Okay, so we have this for a solution, and we have this for a solution. There's really two parts for compound inequalities. And I know it's not fun to graph using words sometimes. If you want to make your number lines on paper, you can do that. Or you can make a number line in Sketchpad, or I don't know exactly how you'd make them in Desmos, but you can try, or GeoGebra, see what happens. Alright, so on these problems you're going to solve these inequalities, and some of them are ORs, like 13, 15 are ORs, and those you would just, the two separate inequalities are already basically given to you. So I'll do a couple of these. I'll do number 12. So my two separate inequalities would be negative 12 is less than or equal to 2 minus 5x. And my other inequality would be 2 minus 5x is less than or equal to 7. So now we solve to get x by itself. So subtract 2. Negative 14 is less than or equal to negative 5x. Now, remember that when I divide by a negative sign, I have to switch the inequality. So I have to take 14 divided by 5. And a negative divided by negative is positive, so 2.8 is greater than or equal to x, which is the same as x is less than or equal to 2.8. So when you graph this part, you're going to be estimating in between 2 and 3. Here's 3. And you can just get it as close as you can. Before I graph, I'm going to solve the other part. Subtract 2 from both sides. I get negative 5x is less than or equal to 7 minus 2 is 5. Divide both sides by a negative 5, and you have to switch the inequality. So now it's x is greater than or equal to negative 1. So the -1 is over here. So when I write this as a combined inequality, it doesn't matter that I did this one first and got 2.8. The lower endpoint is at -1, and my upper endpoint is at 2.8, and x will be in the middle. This one is written the way I want it to be, so I just copy the inequality sign over. This one is written the opposite way. This is the same as -1 is less than or equal to x. So I need this to be less than or equal. So this is part of my solution. You have to write that solution, and then the graph is the other part. So I'm going to use my insert shapes, and I'm going to get a circle, and I'm going to do it up here. Yep, that looks fine. It's a little big. And then I'm going to move it. I wanted to see if it needed to be filled in. If your circle is not filled in, then you pick shape fill, and you pick what color to fill it with. Maybe I'll do red to make it easy to see. Okay, so there's my circle, or my point, and I need one at -1, and it should be filled in because it's less than or equal to. And I'm just going to copy that and paste another one at 3, or 2.8, which is just less than 3. It's hard to get it right exactly on, and you don't have to, don't worry about it. Okay, then you need a line in between them, so go back to Insert Shapes and pick a line, a solid line. There, and I want this to be red, and I want it to be a little bit fatter, so it shows up. So there's it's actually kind of orange, isn't it? That's all right. And you just put that between your 2 points, and that's how you would show the graph for this one. Now once you have these points and this line, you can copy and paste them, so you don't have to keep going to Insert Shapes if you want to use the same ones again. And I'll do one more problem. I'll do an OR one. How about number 15? Number 15 says 2x minus 7 is less than or equal to -3, or 2x minus 3 is greater than 11. So you solve both parts separately using the same rules as you used when you solved equations, remembering that if you multiply or divide by a negative, then you have to switch the inequality. This one I don't have to worry about that. So I get x is greater than 7 for this part, and x is less than or equal to 2 for this part. And this was for 15. So the graph for 15 is below it, down here. So I'm going to use my word tools. I'm going to put a point at 2 and 7. So I'm just going to copy this and then paste it as close as I can get. Okay, so x is less than or equal to 2. It's about right there. Yeah. And then another one at 7. Close enough. And then I need lines, and I'm going to insert a shape and get one with an arrow on it. Because this is OR, they're going to point away from each other. I kind of like these block arrows, they're a little fatter. So I'm going to start at 2 and go this way for that one. And I'm going to copy that and paste it for the other side too. X is greater than 7, but I'm going to swing it around so the arrow points the other way. There we go. And it's kind of long, so I'll shorten it up. There. So now I've got my 2 arrows and my 2 endpoints, and you don't have to get them perfect by any means. This is good. So we've got our work and we've got our solution over here. Oh, I forgot the word OR in between them. That's part of the solution too. So this is the solution and the graph is the solution. There's 2 ways to show these. And then there's a couple problems to solve at the end to try a word problem using compound inequalities. All right, let me know if you have any questions. Thank you very much.